So this part of the lesson is now a new topic in that it's using quadratics to solve other equations. So we haven't actually done this before. I'm just going to quickly, just in case there's anyone who thinks actually I really can't remember how to solve a quadratic like this. If you do know how to solve something like this, just skip this part of the video and start on this bit here. So if you've got a quadratic like this where the number in front of x squared isn't just a 1, just a reminder, we do 3 times minus 4, or 3 times 4 is 12. So we're looking for numbers that multiply to get 12 that we can make minus 4 from. So it's going to be to do with 6 and 2. To make minus 4, it'd have to be minus 6. So remember we put here the 3x at the beginning of each bracket. And then it's going to be minus 6 and plus 2. So I can simplify this bracket here if I divide by 3. And then this one would be 3x plus 2. So I should have put here really solve this equation so that we practice getting our two values of x as well. So for this one, well, x minus 2, so if x equals positive 2, that would be one solution because that would make that bracket there equal 0. And then this one here, well, if 3x equals minus 2, that bracket would equal 0, and so divide by 3, x would have to be minus 2 over 3, so minus 2/3. Right, so moving on to ones like this, which is new, you'll notice that this part here, when you square that, you would get x to the 4, which is this part here. So it's the same with the quadratics up here. When you square that middle term, the x, you get the x squared that's here. So when that happens in other questions like this, where you spot that that middle term squared is this one, then chances are you can use a quadratic equation to help you. And we do that by using a substitution. So you can see that rather than an x here, I've now got an x squared. So I'm going to rewrite this equation, but in terms of a different variable rather than x. So I'm going to use y, and I'm going to say, right, let y equal what this middle term here is. So I'm going to say let y equal x squared. So this bit here would now be, instead of writing 7x squared, I could now write, actually, that's 7y. This bit here, x to the power of 4, well, we just said that when we square x squared, I get x to the 4. So this bit here would just be y squared. So if you're not sure what I mean by that, y squared, well, if I've got y here, if I square this, x squared squared, we times those indices together, don't we? So that would make it x to the power of 4. So this is just y squared because it's x squared squared. Then it's going to be minus 7, and I just said that this bit here is equal to y, so x squared is y, so I'd write minus 7y, and then I've got plus 12 on the end. Now that kind of quadratic equation we've done lots of, and it should be easy to solve. So I can factorise this into y minus 4, y minus 3. Get your two values of y as normal, so it would be y equals 4 and y equals 3. And then you just need to remember at the end, well, actually it wasn't y that equals 4 because y equals x squared. So I'm going to replace that y with x squared. So if I go up here now, so instead of y equals 4, it would be x squared equals 4. And then again, instead of y equals 3, it would be, well, x squared equals 3. And so to get your two values of x for each one, you're going to have to square root it. And I say two values because when you square root, you're going to get a plus and a minus answer. So for this one, x would either be, we can actually work that out, so it would be either 2 or x equals minus 2. This one, we're going to just leave it as a square root, so it would be plus or minus root 3. So you'd get x equals positive root 3 or x equals minus a third. So you've actually got 4 different possible values there of x. Say that you had factorised it and you'd actually ended up with like a negative value here. Well, if it's x squared, you can't square root a negative value. So if that happens, you would just have to say, well, actually that's got no solutions, and just look at the one that you can find solutions for. So you might find sometimes that one of these doesn't work. I mean, it could work out that both of them doesn't work, but the question would kind of set you up for that. It would say, maybe show that there's no solutions. So if you're actually looking for solutions, at least one of these should always work. Right, so the next one, similar kind of thing. So when you square x cubed, that's going to get x to the power of 6. So again, we can make this into a quadratic equation. So this time I'm going to say, right, well, let y equal x cubed. So again, this bit here, well, if it's x to the power of 6, well, x cubed squared would give me this. So this is actually y squared, so it would be 3y squared. This bit here is just y, so minus 8y, and then minus 3. So now I'm going to factorise that. So 3 times 3 is 9. So I'm looking for numbers that multiply to get 9 I can make minus 8 from. So it's going to be minus 9 and 1. So if I put that now into my brackets, so it would be 3y minus 9, 3y plus 1. And now I'm going to divide by 3. So you get y minus 3, 3y plus 1. So my two values of y are going to be y equals 3, or it could be that 3y equals minus 1, and so y equals minus a third. Right, so again, it's not just y that equals that, y is actually x cubed, and because our starting equation was in terms of x, I want my solutions to be in terms of x as well. So instead of y equals 3, actually it's x cubed equals 3. And again, instead of y equals minus a third, it's going to be x cubed equals minus a third. So cubing doesn't really make a difference whether it's positive or negative. We can still work them out and there will only be one answer. So we're just going to do the cube root of 3. So that would be 1.44 to 2 decimal places. And then the cube root of minus a third, so I'll just do minus 1 over 3, so you get minus 0.69. Right, we'll have a look at some harder questions then. Something I did actually mean to say at the start of the video is that I have included on Show My Homework these handouts, so if you wanted to make notes on them as we go, then you can do. Sorry, I've only mentioned that now. But obviously you could go back and fill them in now if you want to. Right, so this one here, we've got the same kind of thing. It looks really horrible, but actually, again, if we square 5 to the power of x, you would get 5 to the power of 2x. So just again to show you, if you've got 5x squared like that, you then times those indices together, so you would get 5 to the power of 2x. So therefore this time it's going to be that y equals 5 to the x. So let's substitute that in. So this bit is just going to be y, oh what am I doing, sorry. It's going to just be y squared, ignore that. Then it's going to be minus 12y and then plus 20. Okay, so this bit here I just said up here is what you get when you square it, so that is why it's just y squared. I didn't know why I was doing that. And now we're going to factorise this, so that equals 0. So we're looking for numbers that multiply to get 20 that I can make minus 12 from, so it's going to be minus 10 and minus 2, so then the minus 10 times the minus 2 gives me the positive 20. So therefore my two values of y are 10 and 2. And I know that actually this time y equals 5 to the power of x. So it would be 5 to the power of x equals 10, 5 to the power of x equals 2. So these are actually fairly simple questions to solve. I think to be consistent, I'm going to do it the same way that I've taught you more recently, but the more like complicated ones, because that is one method that works for all really. So 5x to the power of 10, if I go up here, so if I write log 5 to the power of x equals log 10, bring the x down, and so then you can see it's just going to be log 10 over log 5, but there is another way to do it that you might find quicker, but I'm just going to do it this way for now so that it's the same method all the time. So it would be log, remember just to make your bases the same, log 10 5, so you get 1.43. And then the other one, I mean it's the same kind of thing, isn't it really? See, I will do it, but you are going to get the same kind of equation. So you're going to get log 5 to the x equals log 2, x log 5 equals log 2. So this time it's going to be log 2 over log 5. So where are we? So log 2 over log 10, there we go, 5. Right, so you should get 0.43. Right, so the next one, very, very similar. So if I square that again, I'm going to get 5 to the power of 2x. So let's make y 5 to the power of x. So this bit would just be y squared. It's going to be minus 6y minus 7. So I'm going to factorise that, so I get y minus 7, y plus 1. So y equals 7 or y equals minus 1. Right, so when we start to solve this then, instead of y equals 7, it's going to be 5 to the power of x equals 7 or 5 to the power of x equals minus 1. Right, so again, if I now go here, so it would be log 5 to the x equals log 7, bring down your x, and say x is log 7 over log 5. Right, so you get 1.21. Right, the other one, so if I start to do this, so log 5 to the x equals minus 1. Oh, sorry, log minus 1. Right, so you're going to be x log 5 equals log minus 1. If you work this out on a calculator, it will tell you that there are no solutions, which is quite correct. It's to do with the fact that you can't have log of a negative number. The logarithms are always positive, which you'll look at more in year 13, but basically it will tell you there's an error, so no solutions for that bit. So for this one, you've only got one answer, which is 1.21. Right, the last one is slightly more complicated in that if you squared this, so if I write down here somewhere, so if I squared 3 to the power of x plus 1, that would give me 3 to the power of 2x plus 2, which is different to what I've got here. So what you're going to have to do with this one is maybe try writing it in a different way. So if I know it's 3 to the power of x plus 1, I know that that would be the same thing as 3 to the x times 3 to the 1, because when you're timesing, you add those indices together, so that would give you x plus 1. And then I know that 3 to the power of 1 is 3, so basically it's 3 lots of 3 to the x, like that. So that's what we're going to have to rewrite it as. So it would be 3 to the power of 2x plus 3 in brackets 3 to the x minus 10 equals 0. And then when I square this, I would now get the 3 to the power of 2x. So for this one, y is going to be 3 to the x. It's going to be y squared plus 3y minus 10 equals 0. So that's going to factorise to y plus 5y minus 2. So my two values of y are minus 5 and 2. So again, if I now replace that with 3 to the power of x, and 3 to the power of x equals 2. So if I take logarithms again of both sides, so log 3 to the x equals log minus 5, you can see straight away you're going to have a logarithm of a negative number. So this one, no solutions. This one, so you're going to get x log 3. I think we can start skipping a few steps here now. So x is going to be log 2 over log 3. So that is going to be over log 3. So you should get 0.63. Right, so I want you to now have a go at the questions now that are on Show My Homework. If you get stuck with them at all, send me a message and I will try and get back to you as soon as possible. Once you've done them and you're happy with your answers, then you can either email them to me or you can try submitting them on Show My Homework. If I don't reply to you though to say anything like, oh, like I've had it, then you might either want to just try it again or email it to me, because Show My Homework seems a little bit funny at the moment. It's not always that reliable. Alright, good luck, hope you get on well with them.